Welcome to the Percona Live Online 2021. Unfortunately, we are again online just because of the current pandemic situation in the world. Hopefully, it will be get sooner and it will so everybody can go outside and live a happy life. So, tuning PostgreSQL for high performance and optimization. My name is Ibrar Ahmed, and today's topic is about the tuning the PostgreSQL to get the maximum performance from PostgreSQL. So who am I? My name is Ibrar Ahmed, and I have been PostgreSQL industry since 1998. And I have started my PostgreSQL career in 2006 after joining Enterprise DB, a PostgreSQL company. And since then, I have been in Enterprise DB, and then I joined Percona in 2018 as a senior database architect core database engine. And I'm still working with the Percona. I have authored multiple books on PostgreSQL. And here is my Twitter account, my Facebook, my LinkedIn, and my personal website, pgelephant.com. So about today's topic, I have divided today's topic in 6 different items. The first one is a database performance. It's really important to see what is a database performance, because without knowing what is a database performance, nobody can configure to get the maximum performance from the database. Because we need to see what metrics and what values and what is output we required from the database to see that the database is performing 100% or performing optimally. Then we'll see PostgreSQL has a different modules. So we'll study module in a broad way, like a memory manager, a disk manager, or how PostgreSQL is managing the kernel memory. So we will see these all modules in the second topic. The third topic is how to tune PostgreSQL. So it's the most important part, because PostgreSQL has a lot of tuning parameters. And we will learn the most useful tuning parameter, its default values and its optimum values, and how these values, changing of these values behave, and how PostgreSQL react on that. After configuring and optimizing PostgreSQL, we will learn how to tune Linux kernel. We are not optimizing the Linux kernel generally. We will optimize Linux kernel to get the maximum performance from the PostgreSQL. It's very important, because there are a lot of Linux kernel tuning parameters. We will not touch all of the parameters. We will see only those parameters which are important for PostgreSQL. And we will see why changing the Linux kernel parameter can change the behavior of PostgreSQL. It's also really important. The next part is the parallel query. It's not actually a database tuning parameter value, but in PostgreSQL, there are some configuration parameters which are important for parallel query, because we can change the behavior of parallel query by changing the parameter in configuration files. That's why I have added that into my talk. Then the next part will be the question answer session. So the timeline will be like this. We will see the database performance in 5 minutes, PostgreSQL module 10 minutes, and then PostgreSQL performance tuning 15 minutes, which is really important. Then we will see in 10 minutes, we will see the Linux kernel tuning. Then in 5 minutes, we will see parallel query optimization. You will see some more queries, more slides in my topic, but we will cover only in 5 minutes. We will not give much time to the parallel query. We will see just the configuration parameter of parallel query. And then some tips you will see in the, while we are in my slide, you can see some tips. So we will discuss each tip in between, then we have a question answers. So database performance, the first topic, what is the database performance? I have divided the database performance in 6 different things. Like when we are talking about the database performance, what is the really important thing in the database performance? The hardware. Like if you have a database and it's not performing well, so you can just increase its hardware, buy a bigger CPU, buy a more RAM, buy a faster hard disk, and you will get a good performance. Is that okay? And somehow it's okay that you will, if you have a bigger hardware, it will perform better. But the problem is there is a limit because it involves some cost. Not some, a lot of cost. Like you have a database, a huge database, like it requires 100 GB of RAM. You can have 100 GB of RAM. If you add 200 GB, 300 GB of RAM, then this database performance will be very good. But there is a limit. You cannot add more cost to your database. So if you have a limited database, and the limit can be any, so bigger and small, but you have a limited value. In that value, you have to choose a best hardware to get the best performance. So the first element is the hardware, because it will become a bottleneck sometime. So you have to achieve the maximum from that hardware. So the second important part is the operating system. You have to choose your operating system on which your database system is running very wisely. There are a lot of operating systems available on which you can install your database system, like Linux, Windows, Solaris, HP UX, Mac OS. So you have to choose your operating system wisely, because it's really important that if you have an operating system which does not give you a more freedom to optimize your operating system, then you will be stuck. And you have to see your performance of your database, which operating system gives the best performance for your database. So the second part is operating system. And not only choosing the operating system, and tuning the operating system. So when you choose your operating system, which is configurable, and you optimize your operating system to get the maximum performance from your database, then your second part is good. So the third part is the database. You have to choose your database after selecting the database, or you can say it's vice versa. You choose your database first and you choose your operating system first. So you have to choose a database. So you have to learn your data and your workload, what type of workload you have. So when you choose your database, in this case, we will choose PostgreSQL because the topic is to PostgreSQL. So in this case, when we choose our database, which is definitely a PostgreSQL, then we will configure it. We'll optimize a PostgreSQL. The third is your workload. Workload is really important because you have to think about what kind of workload you have. because it really helps you to choose your database, your operating system, your hardware. It helps because, like, if you have a normal relation database, then you have a multiple choices here. You can choose MySQL, PostgreSQL, Oracle. Other elements are, I'm not discussing the cost and open source and like this. I'm not discussing that. But if a relation database, you can think about that. But if your data is column oriented, then you have to choose some column database like ClickHouse. So workload is also really important. Then it comes to your application. You already selected a best hardware, or you can say within your budget, you get a best hardware, you have selected an optimum, a best operating system, you choose a PostgreSQL as a database, and you know your workload, then it comes to your application. So why I'm saying you tune your application? Because it's really important. If you have a best hardware in the world, you have a best Linux operating system, any operating system, you have a PostgreSQL, a best tuned PostgreSQL, and you know your workload, but your application is badly written. For example, on each query, your application try to connect to PostgreSQL and query PostgreSQL and disconnect. And this happen every 1 second or 2 seconds. So application is correcting, querying, disconnecting, query. So it's just wasting some time. So it's not optimized. It's just a one example. An application can ruin your optimized database. So application is really important, how it uses the database. So when we are talking about the complete application, we come to a module, database module within your application. If your application is good, that if your application is connecting once and just querying database and not sending too many connect disconnect requests to database, it's well-written application, database is okay. But where your queries are not optimally written. For example, if you required some data and you are not pushing your filters, your calls to the PostgreSQL, your database, and handling that filters in your application, that's a bad design. It will affect the performance of database. Like here is an example, select static from foo. Just getting all the column from the table foo, and there is a nowhere clause. So suppose this table has 1 million rows and we required only one row. And we are just sending the select static from foo, and it will fetch 1 million rows, and then we will reject one less than 1 million rows, and then just accept one row and drop all the rows. And it's just a bad example. So I have seen many applications in my life that they have queries which is really, really badly written. The second example is like this is here. If you have a where clause, select static from foo, where id is equal to 1, 2, 3, 4. So we are selecting just one row. But what is the bad in that? We are selecting each and every column from the table foo. So do we need to think that we need all the columns or not? Maybe we need only 1 or 2 columns. Then writing the column names is really important here. The second thing is, if previously this table has 3 columns and you were selecting from table foo, and the backend design changed and the column has a 4 column, you are still writing a select static from foo. You're now selecting 4 columns from table foo. So maybe the application is broken or something like that. So you have to write your query wisely. Now, PostgreSQL module. Second topic is a PostgreSQL module. I have divided that PostgreSQL in these modules. The first one is the clients, which is not actually part of the PostgreSQL database. It's a client. It can be a pSQL, which is actually a PostgreSQL part, but we can say that's a client. So I'm just segregating into the client part. You have written a client using a JDBC. You have a client written in ODBC or libpq. So there are clients. So we are not talking about the optimizing the clients and client side something. So we are not interested in this optimizing in this part. And when the most important thing is PostgreSQL is a process-oriented database. And we say it's a process-oriented, that it is whenever a new clients connect to the PostgreSQL, it spawns another process, and that process is responsible to communicate with the client. So here, when you start PostgreSQL, the postmaster process will started at port 5432. Postmaster process is started on port, which is a default 5432. Can be changeable, but default is 5432 started. Along with that, there are some other processes started, like checkpointer, wall writer, archiver, logger, background writer. Some other process has started, and you see a one postmaster process. Whenever one client connect to the postmaster, here, for example, pSQL connect to the postmaster on 5432 port, then a new process, PostgreSQL spawns. And now this pSQL connect to the PostgreSQL and start communicating with these. And then if another process comes like JDBC, connect to the 5432 port, it will again a new process spawns, and JDBC start communicating with second process. So when if you have 10 clients connected to the PostgreSQL, there you can see there are 10 processes running in the background. So you can always go and see on the database server how many clients are connected. You can PS, you can using top, PS, and any Linux command to get the process name, process ID. So you can see how many processes are running, and you can see multiple PostgreSQL processes are running. It depends on how many clients connected to the PostgreSQL. Then the next module after the process, the next module is a disk management. So when you install PostgreSQL, normally you install PostgreSQL using apt-get or yum, some tool, which already initialize PostgreSQL for you. But PostgreSQL has a command line, which is called initdb. So initdb, when you initdb, that means you are initializing your cluster, and you will provide a directory which is called the pg data to initdb. PostgreSQL create a cluster for you on that directory. The base in that data directory, the base contains the data files, the global files, the wall files, the configuration files, and these all files are into the pg data. So you have a pg data directory, and all cluster file is in that, and with initdb is used to create that cluster. There are some object that can be outside data directory, like table spaces. You can, after that, you can create a table spaces that you can provide a path to the other than data directory. It's separate case, but normally when you're initializing your database using initdb and providing a data directory, it will create a cluster first. After the disk management, you have PostgreSQL memory management module. A shared buffer, a wall buffer, work mem, maintenance work mem. There are some configuration parameters. There are some configuration parameters which are used to manipulate the memory management of PostgreSQL. That's really important. I'm not going to discuss that into that detail here in this diagram, because we will discuss each and every configuration parameter in the next coming slides. Then we have a kernel memory. We will discuss in the next slides that why it's really important for the kernel memory. While we are talking about the kernel memory, it's mean a Linux kernel memory. It's not PostgreSQL kernel, it's a Linux kernel. Linux kernel has normally 4K memory page, and it has a concept of huge pages, which can be a 2 MB or 1 GB, and it has a transparent huge pages concept. So we will discuss all 4K, 2 MB, and 2 MB, 1 GB huge pages and transparent huge pages in the next coming slides. So PostgreSQL performance tuning. Here are some basic tuning parameters that are useful to tune the PostgreSQL. These are not the only tuning parameter in PostgreSQL. PostgreSQL has a PostgreSQL.conf file into the data directory, which can be used, which is used to change the parameter value for the PostgreSQL, and all the parameter values, default values is written in that file. And there are huge number of configuration parameters, but these are some basic configuration parameters. So the first one, the PostgreSQL tuning, a shared buffers. Why I'm talking about shared buffer as a first place? Because it's one of the important configuration parameter. PostgreSQL use its own buffer along with kernel buffer I/O. What does that mean? That means PostgreSQL has its own buffer, and it also using a Linux kernel buffer I/O, and this is called double buffering. It means when we are writing to the data into PostgreSQL, it's not directly written to the disk. It was first written into the PostgreSQL buffer, and that PostgreSQL buffer is written to the Linux kernel buffer, and then Linux kernel buffer is written to the disk. And this whole concept is called double buffering. So data is written to the shared buffer cache. There is a background processor which is used to write these blocks to kernel buffer. So we are not here discussing the kernel buffer. Right now we will discuss that in the later slides. But now when you are writing data, it's written to the shared buffer. So there is a command to see this parameter, which is called show. You can also go and check the PostgreSQL conf file, but you can see the running values are the current affected value of shared buffer is show shared buffers, and it is 128 MB right now. It can be changed. So what should be the value of that? In the next slide, I will let you know what is the value of that. According to the Bruce Momjan, I just quoted his value. It's a hint. The proper size of the PostgreSQL shared buffer cache is the largest useful size that does not adversely affects other activity. That's really important. Why it's really important? Because normally I have seen in the documentation and different documentation on a website that this should be the 25% of your actual RAM. Like if you have 1 GB of RAM, then it should be only 25% of your 1 GB. But I don't agree with that. I have seen people are recommending as a 40% of your actual RAM. I'm also not convinced with that value, because these values are really good when you have a shared database, shared machine for the database. It's in actual words. Like if you have a database, you have a computer which have multiple server installed, and you have also installed a database on that. So it's not good that you give most of your memory to your database and then the other servers will not work properly on that machine. That's 25% is okay for that kind of a machine. But nowadays, people have a separate, dedicated machine for database. So there is no other application is running, a server is running on that server. So all the maximum resources are for the PostgreSQL. So it can be 60% of RAM, because if you just give a 40% of RAM to your PostgreSQL and there is no application is running on that server, so what you are doing with the rest of the memory? I'm not talking that you should give all 100% to the, which is also not possible to give to the PostgreSQL. The 24.5% is also very less. So the Bruce Momjan statement is very true. If it's not affecting any other, and it can be the largest value. So shared buffers, I have just benchmarked with the shared buffers here. Like in the horizontal, I'm just increasing the shared buffer value. And on the Y value, the X value is the shared buffers value, and the Y is the TPS, transaction per second. So you can see that when I have 128 megabit of 128 megabit shared buffer, then I have a TPS of 500. Sorry about that. It's the second one is 256, and the third is 512, which is 6801 and 3023. I just is a typo that's written 128, and 128 is the copy paste error. So in the graph, you have a right value. You see in the 256, we have a 3023 and 512. We have a 6801. And when we have 1 GB of shared buffer, we have a 12898. And when we have a 4 GB, it's a 55352. So we are increasing shared buffer, and the transaction per second is also increasing along with that. But you can see there is some point that it stopped increasing. We are increasing shared buffer 4 GB to 8 GB to 16 GB, but transaction per second is not increasing. So why is that? Because our total workload is around 4 GB. That our total workload is just fit into the shared buffer. So increasing the shared buffer will not give us a more benefit. So that's really important. That if somebody is confusing about the workload, just think you have a complete database size is a 4 GB. Because it's really important the workload, but for the simplicity, I'm saying that you have a total database 4 GB, and you have set the 4 GB in shared buffer. That means your whole database fits in the memory. If you have give the PostgreSQL 8 GB of RAM, there is no use for it. You will not get benefit from it because it's already in RAM. So more RAM will not give the benefit for them. So that's why shared buffer is important. So max connection, this is also a really important parameter. Why it's important? Because it will restrict PostgreSQL to deny any further connection to PostgreSQL. Why? I told you that when we have a application connected to PostgreSQL, it spawns a separate process for that. On the left side here, we have one terminal, and we just connected to the PostgreSQL. In the second terminal, we have this PSQL, and the third terminal we have this. So in these three terminals, I just get the PID from PostgreSQL. That means we have three clients connected to the PostgreSQL, and I'm just getting the IDs from that PostgreSQL. Here on a fourth terminal, I just executed a command, PS command, which will give me the process status, and then grab the PostgreSQL and grab the idle. And you can see there are three processes running. PostgreSQL process running, each process for each client. Like 3214 have its own PostgreSQL running in the background, 3214, 3590, 3616. The three backend processes are running to give this service to three clients of PostgreSQL, PSQL. So if you set that parameter, default is 100, that if you have 100 client connected to PostgreSQL, the maximum value is 100. If you have a 101 client try to connect to PostgreSQL, it won't able to do it because the maximum connection is 100. It can be changeable. You can change it to 200, 300, 400, but you need to have some kind of a resources. So it's really important if you have a large number of connection clients, try to connect to your PostgreSQL, but you knows that the active connection are only 100 or 200. So you can set this value 100 or 200, and you need to install PG Bouncer, a pooler that will help to handle the more connections simultaneously. Because if you have 1,000 of clients connected to PostgreSQL, but normally active connections are very less. So you can have active connection in the PostgreSQL as a maximum connection, and the let's connection pooler handle the rest of the connection. And the best connection pooler is a PG Bouncer. It's available, free. You can download it, install, and you can use it. So next parameter is wall buffer. Do you have transaction? Obviously, yes, because you are a relation database and you are using the transactions. So right ahead log, you have wall because normally data is written to the wall, and wall is used to log your transaction. So wall buffer size is 16 MB with 8K blocks. And this, I'm just talking about the default value. It can be changed. PostgreSQL writes wall into the buffer, wall buffer, and then these buffer are flushed to the disk. So you can change this value. I told you the default value is. What is the default value? You can change it. And what is the optimum value for this? The hint is bigger value of wall buffer in case of lot of concurrent connection, give better performance. If you have a lot of concurrent connections, if you have a bigger value of wall buffer, you can get them good, much benefit from it. So the next parameter is effective cache size. This is used by optimizer to estimate the size of the kernel buffer cache. So you can have a very bigger value of that, but it's really different from shared buffer. When you provide any value to shared buffer and you restart your server, the PostgreSQL will immediately capture that amount of memory. And if you give shared buffer 10 GB, then PostgreSQL will use 10 GB of shared buffer. But when you give any value to effective cache size, it's just an estimate. It's just a guideline, not the exact allocated value or cache. So it's just a guideline used by the optimizer. So it should be large enough to hold most accessible table, but at the same time, small enough to avoid swap. So next one is the work mem. This configuration is used for complex sorting. So when you are sorting your data, it requires some memory. It will not use shape of or something like that because it has to sort in memory. So it will use a separate memory chain. PostgreSQL has configured that it will use a separate memory chain for the work mem. So each value is make sure that each work mem is per session based. Even its granularity is more than that, but it's a session based. Like when we're talking about the shared buffer, when we set the shared buffer 1 GB, then it's 1 GB. It can not be 2 GB, 4 GB right now till you change or restart that. It's 1 GB, then it's 1 GB. But when you set a work mem 1 GB and you are doing complex sorting on multiple sessions, then it will multiply by that sessions. So you have to be very careful. So each value is per session based. That means if you set the values 10 MB and 10 user issue sort queries, then 100 MB will be allocated. So you have to be very careful. You don't have to run out of memory. So in case of merge sort, if X number of tables are involved in the sort, then X multiplied by work mem will be used. Then it's more dangerous than that. It will allocate when required. So it not always be used, but it is required when it's allocated, when it's required. So here is an example. So unlike shared buffer, it can be changed within the session without restarting the PostgreSQL. So I'm just setting the set work mem is equal to 2 MB. I just issue a explain, analyze, select static from foo, and order by ID. So I'm just sorting the foo table result by ID. You can see it took around 13 seconds. It's a millisecond, but divided, it's 13 seconds. So I just ran the second command, the set work mem is 1 GB, and issue a same command for them. And you can see it reduced the time to 7 seconds. So when you're sorting, so it's really important, you can see the sort time is actually reduced. Actually, the sort time is reduced. Why sort time is reduced? Because we provide more memory to the sorting algorithm to store the sorting result into the RAM. So, like work mem, the maintenance work mem is another parameter which is also a session based, but this work mem is used for maintenance tasks. The work mem was used for the sorting, but this is for the maintenance tasks, maintenance work. Default is 16 4 MB. So what is the maintenance? Maintenance means vacuuming, restore, create index, add foreign key, alter table. So these are kind of maintenance tasks which is using the maintenance work mem. So for I have an example. Set maintenance workman is equal to 10 MB, and just show workers memory 10 MB. I just creating an index on table foo using ID. It took around 12 seconds. I just changed the maintenance work mem to 1 GB, and I just created an index on that, and it took 9 seconds. So this is also per session based, and it does not require to restart. You change for the per session, and you can reset that value again back to the normal value. So when you're increasing that and you are performing some maintenance activity, you just change this value and perform that maintenance activity, and it will perform quicker than that. Synchronous commit. This is used to enforce that commit will wait for val to return on disk before returning a success status. So when you have a synchronous commit on, that means that commit will wait for the val to be returned on disk. You will not get a success status until you get the success status from the disk. So if this parameter is R, you will get a success status before getting the success status from the disk. So what is the benefit of that? It's give you a more speed if this value is off. But if this value is on, then it reduces the speed, but it will increase the reliability. So it's trade-off. You need more reliable, then decrease the performance. If you increase the performance, its reliability will be decreased. So it's a vice versa. So one thing which need to be very clear, the synchronous commit does not introduce the risk of corruption, which is really bad. Just risk of data loss. So you will not get the corrupt data, but some risk of data loss is there. Checkpoint timeout. Checkpoint timeout is very important because PostgreSQL writes data into the val, and the checkpointer process flushes the data into the disk. So when into the data files, so when it should happen, there are multiple scenario where it should happen. One is you just issue a checkpoint command, and then the all val files data flush into the data files. But you want to automate that process. If you want that to automate process, you just set the checkpoint timeout like 1 hour. So every 1 hour, all the data file flush to the data files. You can set that to 1 day, 2 days. But longer the checkpoint timeout, the more it increases the recovery time. Frequent checkpoint means less recovery time, but it will impact the performance. If you do checkpoint more often, then it will increase the I/O. And if it's increased the I/O, it will hit the performance. But if you have a very big value of checkpoint timeout, it will decrease the I/O. It will give you the good performance. But if database crash, then recovery time will be very high. So the fourth, the Linux tuning for PostgreSQL. We mostly cover our main topics, but we have 5 minutes for the Linux tuning for PostgreSQL and the 5 minutes for the parallel query. So I have already discussed that PostgreSQL use direct I/O because there is sorry about that. Postgres use a double buffering. Postgres does not use direct I/O. So there are 3 concepts: direct I/O, buffered I/O, double buffering. So PostgreSQL use double buffering. PostgreSQL believes that kernel knows much better handling of I/O and storage and everything. So PostgreSQL has its own buffering. and it writes to its own buffering, and this buffer written to the kernel buffer, and this kernel buffer written to this, and this is called double buffering. The bad thing about that is it increases the use of memory. And the second bad thing is that different kernel behave differently. Because if you have a Windows, then Windows handling of kernel memory is different. Linux handling of kernel memory is different. So different operating system behave differently. That's a bad thing. So virtual memory. So it's just a concept that every process is given impression that it's working with the large contiguous section of memory. So when you are running a process, so every process seems that it has its own RAM. In a very vague one, it has its own RAM. It has its own address space, dedicated. But it's not possible actually, because we have one physical RAM. We don't have that much amount of physical RAM. So every process has access to the virtual memory, and there is a which maps to the actual physical memory. So how this physical memory maps to virtual memory, it's a academic question that how we achieve that and that. But just keep in mind that we have a virtual memory. Every process has each virtual memory, which seems like it has its own dedicated memory, which is mapped to the actual physical memory. And there is a translation Lookside buffer, which is called TLB. It's a memory cache. It reduces the time to access the user memory location. If the match is found, the physical address of the page is written. If match does not found, then its cache TLB miss. So TLB hit or miss, we have a two item here. So it will find that the physical page, the page is found in the physical address of the page, is then it's returned, otherwise it's missed. So this is the table. So small. So operating system is maintaining this table to map to get you maintaining this cache to get you the actual table. So if you have very large amount of small tables, small pages, then the TLB size will be increased. It has to manage large amount of pages, millions, billions of pages, small sizes, billions of pages. Then size of this cache will be increased. So traversing this cache become expensive. So now I'm just give you the example that how Linux handle its memory management. It's just a vague idea of that. So different OS have different size of pages. Linux has a different page sizes like 4K of normal pages, classic huge pages, transparent huge pages. BSD has super pages also. Windows has large pages. So as I discussed, that Linux page size is 4K. So that means its TLB size is very huge. So if you have 256 GB of RAM, consider how many pages it has and how many entries will be in TLB. So we are not, so Linux introduced a concept of huge pages, which can be 2 MB or 1 GB. There is only two values of that, 2 MB or 1 GB. It's very huge pages, because if you compare it with 4K, you can see that it is 2 MB is huge and 1 gigabit is also too big. So how you can configure it? You can just go to the grub and you can change grub into 1 GB, or I've just written it as 1 GB, 1 GB, and you can change it 2 GB or 1 GB, update the graph, restart your computer, and it will be 2 GB or 2 MB or 1 GB. In PostgreSQL, it required some special handling. That in PostgreSQL.conf is just written 10. If it's all depend on what version of PostgreSQL you have, it can be 13, it can be 12, 11, something like that. In PostgreSQL.conf file, you can see a huge pages parameter, and default is try. So what does that mean? PostgreSQL will use a 4K pages. Along with that, it will also use the huge pages because we set it on. If we set it off, it will not use the huge pages. So what is the value means try means? Try means PostgreSQL will try to use huge pages if it's available on operating system. If it's not available on operating system, it will not use and start successfully. So if the value is try and operating system supports huge pages, it will use huge pages. And if operating system does not have huge pages, it will not use and start successfully. If you set that value on and operating system supports huge pages, then it will start successfully and start using huge pages. And if this value is huge pages is on and operating system does not support huge pages, then PostgreSQL will not start. Because you are explicitly saying use huge pages on and operating system is not supporting, then PostgreSQL will start. Try means try if you can use it, otherwise just start. It requires a restart. So Linux has another concept of transparent huge pages. That means you don't have to configure in PostgreSQL conf and anywhere in that, it will use automatically the Linux huge pages. But the most important part is here is that it is I have read in many blogs that it will not give you much benefit of that. Even I have seen that it degrades the performance. I have seen some blogs about the Mongo, MySQL, and some different databases. I just can't remember how many. They are not recommending to enable the transparent huge pages for the database. So I just have also written a blog on that, how to disable it. So, but you can see that echo never and kernel parameters change. You have to change the kernel parameter never here. So it will disable transparent huge pages. I have benchmarked the classic huge pages also and transparent huge pages also. And classic huge pages give a really benefit, but transparent huge pages does not give any benefit. I will attach a blog post at the end of the talk. So swappiness, another parameter. The swappiness means how much this is a kernel parameter that affect the performance. Used to control the swappiness. So the parameter is 0 to 100. That means how much your data, your system should swap. Higher value mean more aggressively swap. If you have a value 70, 80, that means it will do more swapping. If you have a value, less value, 1, 2, 3, it will not swap. Or less swap. 1, 2, 3 mean less swap, very less. So used to control the swappiness pages to swap memory into the RAM behavior on a Linux system. So sudo sh-c equal 1. If you want to change the value to 1, just change the value into the 1. So don't set that value to the 0, because if you disable, it will disable the swappiness, which is not mostly not recommended. But I get much benefit by setting it a very low value of that. database performance is really good when you set that value very low, because you are not swapping, because it's all dependent how much memory you have. You want more aggressive swap, then increase that value. If you want to less aggressive swap, then set that value very low. So another parameter that normal the application allocates the memory and does not use that value. So normally operating system overcommit that value, and when this value, the memory is used, then it will allocate then. But that's really dangerous, because if operating system overcommit you some memory, and at the time when you want that memory and operating system does not that have value, then OOM, out of memory killer, a process will invoke and it kills your application. So normally, here is 0 by 0, the value of overcommit value 0 is heuristic, intelligently default values and heuristic value of kernel heuristic value based on kernel heuristic. One mean always overcommit. If you set that value, it will overcommit, and when that application required that amount of memory, if it's available, then it will allocate, and if it's not available, it crash. That application will crash. It's also not recommended. Normal recommended value is 2, because it's safe. 2 means overcommit, but don't overcommit beyond that ratio. That if you just overcommit some memory, but don't overcommit beyond that ratio. You set some ratio that don't, here I said 2 value, and don't overcommit 50% of the RAM. So I think we are running out of time. So there are some other parameters. We just want to cover some parallel query optimizations. Actually, because of short of the time, sorry about that. I'm just quickly want to cover into to 4 minutes to the parallel query, because it has some parameter to configure. So how parallel query works? When parallel query be used, parallel plans, parallel safety, these are the parameters we need to consider. The first one, the configuration. The most important thing is the configuration, because the other things are not as important for as a DBA, because mostly the queries are written by the developers, not by the DBAs. But the configuration is mostly the configured by the DBAs. So max worker process, the default is 8. These values are also need to be changed in PostgreSQL.conf file. It sets the maximum number of background process that the system can support. So it is the hard limit that you are setting the maximum number of background process. When a query is running up different worker process, so you are limiting that to the 8, because default is 8, you can change that value. Maximum parallel workers per gather, the default is 2, sets the maximum number of workers that can be started by a single gather or gather merge node. What is the gather merge node? When we invoke a different worker process, and different worker process get the result, and then one process need to gather all the value to merge that value. That is called a gather merge node. So I will let you know in the next slide what is actually in the by showing in a picture. Maximum worker process parallel workers is default is 8, sets the maximum number of workers that the system can support for parallel query. So you can change that. Default is 8. Dynamic shared memory type, you can change the type of dynamic shared memory. Here is a POSIX. So their value should not be none. POSIX, SysV, Windows, and map. You should need to set that value according to that. Parallel workers, integers, set the number of workers that should be used to assist the parallel scan of this table. So here is I will give you an example because we are already passing 1 hour. Explain, analyze, select, count, static from foo. You can see the worker planned are 2 and worker launched are 0. So why worker launch is 0? That means it sees the optimizer sees that the query can work much better if there is a 2 workers, but the worker launch 0. There can be 2 reasons: max worker process or max parallel workers. You need to check the value of these 2 parameters. The second query: explain, analyze, select, count, static from foo. You see workers planned 1 and workers launched 1. Now, how much is planned and how much is launched? So check max worker per gather or max worker. You need to check these 2 values to increase the worker plan or worker launch. In first example, you need to have worker launch also 2. So you need to configure these 2 values to have worker plan 2 and worker launch 2. In this example, worker plan 1 and worker launch 1. So importantly, previous example, I said that you can set that in PostgreSQL.conf file. Your parallel worker, you can set that into the max parallel worker per gather, parallel worker, max worker process in PostgreSQL.conf file. But important is you can also set parallel workers per table base, that if that query is on that table, if their scan is happening on that table, that how many parallel workers it can start. So here the value is 2. You can see alter table foo set parallel worker is equal to 2, explain, analyze, select static from foo, and you can see now you can see worker plan 2 and worker launch 2. Here worker plan 2 launch 0. Here not planned and not launched, only 1 and 1, no parallelism. 1 and 1, no parallelism. Here then in last you can see the parallelism. So these are some parameters you need to configure and change and manipulate to get the maximum performance from that. So I will provide these slides on this side, so you can get all these values from that, because we are out of time here. So, but the main topic is not the parallelism. I just want to show you the how parallelism work, how some parameters exist to tune PostgreSQL parallelism. So here are the 2 blogs that tuning PostgreSQL database parameter to optimize performance, PostgreSQL tuning. The second was the Linux tuning. So you can also get more blogs or Percona site or my personal website is pgelephant.com, and you can reach me Ibrar at Ahmed@percona.com. So if you have any question, so I'm happy to answer that.